Everyone, thank you so much for coming to this talk. Last time I spoke here 2 years ago, I came to talk about the work we were doing to kind of modernize and re-engineer Hibernate and create Hibernate 6. And I came with a lot of trepidation. I wasn't sure that anyone was going to be interested to hear about it. And it turned out that you guys did come along and were interested in the topic. So it turns out that object relational mapping in Java is still a topic people are interested in. And like a year, kind of this time a year later, it became clear to us that in fact Hibernate 6 has been a smashing success. That's reflected in all the metrics we have. And against that background, we've realized that it made sense to go back and try to revitalize what's going on in the Jakarta specifications with respect to persistence. So first of all, I got involved in Jakarta Persistence, a specification which I'd been very involved in creating many years ago. And it was great to come back and see how the specification had evolved and see what things were still missing that we didn't know then that we know now. And so we've done a lot of work on that. And a more interesting story is what happened with Jakarta Data. So Jakarta Data was originally a specification which really didn't have much interest in. And in fact, we kind of hoped it would go away. And it didn't go away, and it turns out that was a good thing. So by the time it became clear to us that it wasn't going to go away and that we had to engage with this, luckily, by that point, we had actually had some good ideas about the direction it should evolve in. So I'm going to start this talk talking about why I was wrong about repositories. It's always good to be wrong about well, no, that's not true. It's usually much more satisfying to be right about things. But if you're going to be wrong about something, be wrong about it in a way that gives some insight into how the world could be made better. So I'm going to make some statements here which you don't have to agree with. And I'm not going to even try to particularly to convince you they were true. But from my perspective, a year or so ago, or a year or 2 years ago, it's what I believed, and it was the perspective I had then. And I want to show you guys then how that perspective, which I had at that point, motivated the changes, which are coming, and the changes which are coming in Jakarta Data, or have come, in fact. So, why change my mind about repository? So I would have said, if you would ask me a couple of years ago, what do you need a repository for? The JPA Entity Manager is a generic repository defined by a standard with multiple implementations, okay? Designed collaboratively as a collaboration between the people who develop the leading Java ORM solutions, okay? Leading solutions at the time and the leading solutions still today. What precisely do you gain by hiding JPA behind a non-generic proprietary framework, which, in my opinion, as I'll proceed to argue, provides no additional type safety, no extra additional incremental capabilities, and in fact makes it harder to get access to some of the capabilities that JPA does have. And I guess the point here is that if we could have made JPA simpler, like we would have done that. An attempt to simplify JPA is, to my mind, kind of misguided, right? The things which make JPA complex are real and they're useful. Okay, all these operations which you have available to you are useful operations. And to make the point even stronger, I would say that out of the thousands of critiques of ORM that I've read over the years, many of which I think are misguided, the one complaint that really stands out to me as most reasonable is the complaint that using a persistence library, particularly an ORM solution, particularly one with a stateful persistence context, takes you further from direct control over your SQL, or direct control over your interaction with the database. And I'm going to say that repository frameworks make that worse. They can't not make that worse. They're an extra layer, okay? Now, how much worse they make it, well, there maybe we have some room for negotiation, all right? But essentially, the more they're doing, the worse that problem becomes. And this is especially the case if the repository framework attempts to abstract over two very different things. One thing is a CRUD-oriented, insert, update, delete type API, where you have full control over the interaction with the over the timing of the interaction with the database, where there's no persistence context caching entity data, and a JPA-style stateful persistence context. These are completely different, fundamentally different programming models. You cannot reasonably and effectively abstract over the two models, and if you try to, you will create all kinds of confusion in the mind of the user. You, as a framework developer, are creating confusion and for your users. And we see that every day. We see people coming and and they believe they're using JPA, but actually they're using this other thing which abstracts over JPA, which has its whole own idea about what the programming model is, and so they're left in this netherland. Another thing I didn't like is that typically repository frameworks are designed so that each entity has its own repository. That typically you extend some interface which is parameterized by the entity type. And, okay, it doesn't sound that terrible. Issue is that lots of interesting operations in a relational database, okay, I'm not talking about any other kind of persistence technology, but in a relational database, lots of interesting operations operate across multiple entities. So, for example, and it's something I keep emphasizing over and over again when I'm talking to people. In a relational database, the most trivial, off the top of my head examples I can come up with is things like author book. It's a many-to-many association. Things like student, professor, class. It's like many-to-many associations. Relational data is chock full of many-to-many associations. Queries that operate across relational data do not come in as some domain-driven design type people would have you believe at some top entity and then navigate it down a tree. That's not how relational data works. If you try to shoehorn relational data into that mentality, you'll make life difficult for yourself, in my opinion. So, to my mind, a repository shouldn't be, we shouldn't be thinking about individual entities and operations on individual entities and maybe their subtree of things, their aggregate or whatever the DDD people would say. We shouldn't be thinking like that. That doesn't make sense for relational data. And so we should be able to have a repository operation which operates across several entities. Now, you might think that this is a pretty, trivial sort of a concern to have. But I'm about to argue, well, I'm not sure if I'm about to argue it, but I'm at least about to assert it. I'm about to say that organization is one of the main things that repositories are offering you, okay? The ability to be able to organize your queries is one of the things that I think people get out of them. Finally, we see in the repository frameworks that exist in the world today that they've been inspired by Ruby on Rails, and in an effort, a certainly well-intentioned effort to make it easy to write, the kind of most trivial queries, find a, book by its title. They've gone for this idea of kind of automatically inferring the query, what you mean from the name of the method of the repository. What this ultimately boils down to is creating a query language which is to be embedded in the name of a method, which means no white space, no punctuation characters, very limited capabilities. And in fact, when you look at examples, I didn't make these examples up, these are real examples. You find you end up with method names like find first by order by last name ask, find top by order by age desk. This is awful. People, let's stop with that, okay? When I create a method that's supposed to, be something with semantics, that has a purpose and a role in my program, that runs a query, one of the main things I get out of making, especially if you write code like I do with lots of little methods, right? the purpose of, one of the great purpose of making the method is that I sort of give it a name, which means something to the person who comes along after me, right? If I don't have control over the name, I'm taking away a main part of communicating with the caller of this API, okay? Yeah, sure, you could say, oh, well, I'll put the purpose of this in a comment. Okay, but that's backwards, guys. Like, if we're going to go to that point, I want to put the comment in the method name and the query in the annotation, okay? All right, so all that said, it is, never the case that when you have thousands of people, probably I don't know what percentage of the people in this room, who like something and they use it all the time, there's some good reason behind that, okay? I don't know what it is for every one of you guys who use repositories. I'm sure you have good reasons. If we were in a different kind of a room rather than a room full of this big people, this is where I would start asking you guys. I'd actually love to hear your answers, but I don't think that works here. So I'm going to, speculate about what some of your reasons might be. I may be off the mark with some of this, but first of all, I believe that, based upon what people used to say, 10, 15 years ago when this repository thing used to be called a DAO, right? I believe that one of the main justifications which was given back then was that having this persistence layer, these DAO objects, was a way of decoupling yourself somewhat from the underlying persistence technology, making it easier to change from using, say, JPA to using direct JDBC code or whatever, or maybe change from Postgres to Mongo or something like that. I believe that it is now, that this is now no longer a common belief, and I certainly don't believe it. Let's say it's marginally useful for that at best. I wonder if the fact that at least I have a method there that I call, rather than writing some a query in a string, and then these set parameter methods which are untypesafe. Queries in string look untypesafe. I wonder if people think kind of feel emotionally that this is more typesafe. In fact, I would argue that this is not true. Repositories, as they have been traditionally implemented, do not provide additional type safety. And the final reason is that I think maybe really, ultimately, end of the day, it's just a convenient place to put all these queries, right? I think it feels uncomfortable and it feels messy to put the JPA code, which does a create query and passes in a string, set parameter, set parameter, set parameter. I think it feels messy to put that in the business logic, which is doing work unrelated to persistence. And so I think, my conclusion from this, and which may be wrong, is that one of the main reasons for even doing this is to have a nice way of organizing code. And organizing code is important, right? So, I missed a slide. Okay. So, I said I was going to talk about how I was wrong. I'm going to do that by saying, how could we make the things I've just stated to be wrong? So what if the implementation of the repository layer or the repository framework was so trivial and so transparent that it didn't get in the way of debugging or understanding the code, that there was no extra layer, really, non-trivial extra layer separating me from the interaction with JPA and the database. There was in particular, no confusion between CRUD-style repositories and stateful persistence contexts. What if we found a more elegant way than embedding in the method name the idea of a way to express trivial queries? What if the architecture didn't restrict how I organize my persistence operations? And what if repositories finally, and most importantly, actually did enhance type safety? All right. Then I would have to, suck it up and say, well, maybe repositories aren't so bad after all, right? So the enabling technology here is annotation processing. All right. So I understand that annotation processes have kind of a bad rep in some circles. I want to say that annotation processing is kind of macro. It's a powerful language feature. Like any powerful language feature, it can be used to do really great stuff. It can be used to do really harmful stuff, let's say. And so it's this it's a sharp knife. Now, with respect to annotation processing, I understand that a lot of people have experience with annotation processes which go beyond what they're sort of officially allowed to do, okay? There is one particular annotation processor which is very well known to you all that I have no reason to criticize. I've never used it. I have no idea whether it's good or bad. I have nothing against it at all. But it's very well known, and it definitely does the things you're not allowed to do. I've written an annotation processor like this myself as well. In fact, part of our Jakarta Data implementation descends from an annotation processor which was like this, which used private APIs in Java-C and ECJ, and which, well, we didn't change generated classes, but user-written classes. I think what's important is that Jakarta Data has been designed so that it can be implemented by an annotation processor which does not need to break the rules about what annotation processors are supposed to do, okay? So if you have had some bad experiences with some other annotation processors, that doesn't necessarily mean you'll have a bad experience here, and I don't think you will. So let's give a quick introduction to repositories in Jakarta Data. Am I going on time? Okay. Slow. All right. So I'm going to talk to you about, so big disclaimer, I'm going to talk to you about using Jakarta Data for accessing relational data, and in particular using Hibernate. Jakarta Data itself is much more than that. Jakarta Data is a generic specification which can be used to implement repository frameworks for accessing non-relational data. If that's what you're interested in, you should go and look at Eclipse JNoSQL, which is targeting that. There are at least 3 implementations of Jakarta Data at the moment, one by IBM, one by Eclipse, and one by Hibernate. So what does a repository interface look like? Just that, okay? It's just an interface with a repository annotation. It doesn't have to extend anything. It can if you like. There's that option if you prefer that, if you think I'm wrong about that. And to get an access to this, you can inject it using CDI or whatever injection you like. In our implementation, especially for testing, you might like to instantiate the repository using new, and that's how you would do it. But this is specific to Hibernate. We don't have a way to do that yet in Jakarta Data in a standard way. All right. So the first kind of operation, the get operation. Get me a book. What do I need to do? I need to write a method. It needs to return book. Okay. First of all, that's what determines what type a repository operation returns. The return type of the method. Oh. And it needs to be annotated find. Now, what's interesting here and what's new is that the parameters of these methods are checked against a field of book. Okay, so they must have the same type and the same name as a field of book. And this can be validated at compile time by the annotation processor. So if you misspell ISBN, or if you think it's long or something, you will get an error immediately at compile time, okay, not at runtime. And importantly, the name of this method is never significant. Okay, you can call these operations whatever you like. They don't have to be called by something that's defined by the repository framework. The repository framework doesn't define anything at all. And as you can see here, we have an operation that operates on books, an operation that operates on authors. So we have this freedom to choose one repository for entity, if that's your jam, one repository for all the entities in your program, if you have a small program, or, what I kind of like, a repository dedicated to kind of a group of little related entities, if that works for you. They can even be, distributed in other ways if you have, particular kinds of clients or whatever. And the idea here is let 1,000 flowers bloom. So what about updates? Okay, so again, here we annotate a method. It accepts a book. That's enough for the repository, for the annotation processor to know what it's supposed to do. Note here that update is an explicit operation. all right? Jakarta Data repositories are always stateless. There is no, as of Jakarta Data 1.0, there is no persistence context here, ever. So in Hibernate, in our implementation, repositories are backed by a Hibernate stateless session, okay? Now, if you want to get hold of this stateless session and do stuff with it, Jakarta Data also provides a way to do that. You just declare what's called a resource accessor method, which is a bad name, but that's the best I could come up with. And you can use it in a default method. For example, you can call upsert, right? So let's talk more about queries. So what we've seen are what I just showed you are parameter-based query methods. So they're query methods where it's the parameters of the method which determine the restrictions upon the results, and it's the return type of the method which determines the entity which is being queried. There are more capabilities I'm not telling you about here. You can go and read the spec, or you can go and read the documentation on Hibernate or Orc about what they can do. What I do want to say is that in our implementation, parameter-based query methods map to a JPA criteria query, okay, which is completely type safe. I hope I have time to show you how that works. This is all just a convenience for trivial cases. So JDQL, the Jakarta Data Query Language, is much more powerful and flexible. Okay, and here you can embed a query in an annotation as God intended. Right? And now you're looking at me saying, "Oh, but where's the type safety in this? These are just strings in annotations." Okay, that's rubbish. No. You know, what about the type safety here? What if this parameter name doesn't match the or the type of the parameter doesn't match the parameter of the method? What about if book has no attribute called title? Well, you get an error at compile time, all right, in our implementation. Now there is significant machinery behind this, guys. Like this was not something we just implemented in a couple of days. But the thing about it is, it's apparently not that hard to build this machinery, because not only do we have this, but IntelliJ also has it. Okay, so IntelliJ is also able to do this kind of validation, which is even better. So you get 2 layers of validation which go on every time you compile your code. So JDQL is a subset of JPQL, restricted to be implementable on a wide range of relational and non-relational data stores. Okay, so that's important. It's a subset, all right? It can be implemented on quite simple data stores. Jakarta data implementations which are backed by relational databases, however, it's strongly suggested that they should support all of JPQL. In particular, in our case, they support all of HQL, which is now an extremely powerful language. I'm not talking about the power that's been injected into Hibernate 6 recently, but it's there. So what about if a query is more dynamic? Okay, here we see that we can do projection and restriction and sorting and all that kind of stuff in a query method. But what if some of that stuff changes depending upon runtime conditions? Well, Jakarta Data has that too. So you can pass in a page request object, which specifies pagination. You can pass in a sort object, which specifies dynamic sorting. And now, of course, you want to know how is this type safe? Well, it's type safe via the Jakarta Data static meta model. Now, you guys might be familiar with the Jakarta Persistence static meta model, which was designed originally for use with criteria queries. And this is something similar to that. Unfortunately, now we have underscore. Now, unfortunately, if you're using JPA and Jakarta Data together, you're going to have a book underscore and an underscore book class in your program. And I apologize for that, but it was the best we could do. But you can see that we can specify the sort order of this query using book underscore book ISBN ask, and that's completely type safe. Now I'm going to take a little tangent. I hope I do not spend too much time on this to talk about something which comes up. This is not really, exactly the topic of my talk today, but it keeps coming up, and I think it's interesting. And the question is, can Java records be entity types? We all love records. I love immutable types. It's great. They're great. And I think the first thing to realize is that immutable types are great for representing trees. Okay? You can go as far as doing linked lists and stuff. So you can have, you can have tree with, multiple branches. I don't know how to say that. Anyway, you know what I'm saying. You can have linked lists. But what you can't have is, try it, right? You can't have circular references, okay, with immutable objects. You just can't set them up. So what kind of data makes good trees? Document databases, they're awesome trees, okay? They're trees by nature. But relational data isn't made of trees, okay? And I come back to something I said earlier, right? Relational data is full of many-to-many associations, and in fact, that's what makes relational data so much more powerful than hierarchical models, okay? Is that these many-to-many associations are easy to represent and natural and part of the whole model. So while some Jakarta Data implementations will support records as the entity types, it's not required by the spec, and Hibernate's ORM-backed implementation will not support that, okay? Just in case, because otherwise I know somebody's going to ask me. On the other hand, records make great embeddable types, okay, as in JPA, and that's why this is a thing which is now required in JPA 3.2, and hopefully that provides me something of a segue into talking about Jakarta Persistence. Okay. So JPA 3.2 is a lot different to Jakarta Data. It's not introducing, it's a 3.2 release, okay? We held off on introducing, wonderful new things into it. What we did do was we sat back and looked at what are the things that both Hibernate and Eclipse Link have and have had for years and years and years that could easily be standardized into the specification. We looked at, where are the rough edges in these APIs? Where are the things which are on Typesafe? Where are the things which are unnecessarily just a pain in the butt? And I'm going to talk to you about just two things today, just to give you a taste and show you that we've done some work. And one of them is making testing easier. So first of all, there's again several interlocking features here, none of which is that exciting. But excuse me. First of all, there's a way to completely configure and start up a persistence unit, an entity manager factory, completely in Java code. How do we go this many decades without having that in the spec? Okay, it's an obvious thing to do. So you don't need persistence.xml anymore to start Jakarta Persistence, to start an entity manager factory in your tests. This class is extensible so that implementations like Hibernate and Eclipse Link can have their own Hibernate persistence configuration with their own specific configuration. Secondly, it used to be that exporting schema was always something controlled by property settings, all right? Property settings is something I don't love. Now there's an object called a schema manager, which you can use to export a schema or drop a schema. This is super useful in tests, okay? You can use it to validate the schema, and what's even more useful in tests is that you can truncate all the tables in your database after running a test. This is much faster on some databases than dropping all the tables, okay? So this is like super useful for testing. Finally, there's a way to call, to run some operations in a transaction with an entity manager without having to write a bunch of try catch or worry about, having to run it inside a Java E container, okay? So this automatically handles transactions and exceptions. This was just an easy low-hanging fruit. Obviously, type safety is, a major thing of what we're trying to do across all this work. And so the first and lowest hanging fruit here is to provide a way to provide type-safe references to attributes, to fields of our entities within annotations of other entities. This is especially super useful for the map, famously the hated map by member of the collection annotations like many-to-many, okay? So now the Jakarta Persistence, not Jakarta Data, static metabol, has these attributes like uppercase book generated into it with the names of the fields of the entity. So that's nice. What about name queries and named entity graphs? These are these things with these stringly typed names. How could we make it easier to make use of these things? Worst of all, I mean, not only would you have stringly typed names, but also JPA prior to 3.2 didn't have a way to determine the return type of a name query, and so you had to do typecast and stuff. So the answer here is, once again, we generate something into the static meta model, okay? And in this case, it's a type query reference. And so I can just do any manager, create query, pass in the type query reference, set the parameters, get the result, and the result will be the right type string here, because if you look back at that previous slide, the query returned a string. Note that we didn't actually explicitly say anywhere that that query returns a string. This is just, once again, a function of the fact that Hibernate is very good at now reasoning about things at compile time. Similarly, we can have a typesafe reference to a named graph. Look, I named entity graphs in Jakarta Persistence are one of my least favorite features. The syntax is really bad. So I prefer for this to make use of just entity graphs defined in code. Unfortunately, the API for this prior to JPA 3.2 also had lots of problems, but we've cleaned that API up now, and now you can write Typesafe, again, book authors, it's using the things which previously existed only for criteria queries, and you can write some nice Typesafe code using entity graphs. We also replaced the idea of, previously operations like find and refresh and lock. Yes. Accepted properties objects with options which you could use to customize the behavior of the entity manager. Now some of these things are type-safe options, okay? And this is extensible so that Hibernate or Eclipse Link can add their own type-safe options, and this really cleans up this kind of control over the behavior of these operations. So what's next? So two things. Of course, we want to make it easier to get more out of JPA when using Jakarta Data, okay? Which means we're going to have to find ways to expose more of JPA through repositories. But we also want it make it easy to implement Jakarta Data, making use only of JPA standard APIs. Okay? So in particular, we already knew in the JPA group that we needed a stateless entity manager. Okay? That's been outstanding for years and years. We didn't do it in 3.2 because it was a .2 release. Maybe that was a mistake. Okay? Because Jakarta Data now makes the need for this thing even more acute. In our implementation, we have to use non-standard features of Hibernate to even start. In my ideal world, you should be able to implement Jakarta Data on top of JPA with no need to call any non-standard features of the underlying JPA implementation. Jakarta Data itself should also support stateful persistence context, okay? And that means a new API, essentially, along with at insert, update, at delete annotations. We're going to need persist, merge, remove, refresh, lock to model the entity life cycle, which is defined by JPA. And so, we sidestep the problem of this confusion I talked about earlier by providing both ways, but making it very clear that they have very different semantics. Okay. We want to reduce the kind of distance. Currently we have these parameter-based query methods, which are very limited in some ways, but kind of cute and nice. And then we have JDQL on the other hand. We are currently looking and investigating ways to kind of reduce the distance between them. My preferred way is to kind of make it possible to kind of break up your JDQL query into little things which can annotate at the parameter level. The IBM folks have their own ideas. That's under discussion. And that's for me ranting. What I want to do now in 15 minutes, that's plenty, is show what some of this looks like. Ooh. So here we have a repository interface. As I promised, it's just an interface with an annotation. the Hibernate annotation processor generates a CDI bean, quest scope. What it actually generates depends a lot upon what other libraries you have in the class path. Here, if I had, for example, Quarkus in the build path, excuse me, then it would generate somewhat different code that works with Quarkus. We can see that it injects a stateless session, and that's about it. That's interesting. So let's say I add this, very simple find method. Okay, find a book by its ISBN. Then you can see that the code that's generated is really easy to understand, guys. Like, this is what you would write by hand. Now, what's there that's a bit messy? Okay, there's a conversion of exceptions, which you maybe wouldn't write if you were writing this by yourself. That's a bit messy. But otherwise, it's just a call to session.get, book.class, ISBN. All right, you can understand this. This is not getting in the way of your enjoyment of Hibernate. In fact, you could take that method, you could copy it, you could paste it onto the library interface and add default, and it would work. Okay, and you wouldn't need to change it at all. All right, so what happens then, as I promised, what happens if I misspell this parameter name? Get a sensible message. No matching field named ISB and entity class devox.book. All right, what happens if I give it the wrong type? Let's say I make it long. Matching field has type string. Even tells me what type I have to make it. Now this is a lot better, guys, than like having that error happen when I run the code, when I run my tests. I could do more than that. Let's say I want to find a book by its title. If I'm not sure it's going to be there, I could even have it return an optional for those people who like optional. Again, this time we're running a criteria query. This looks a little scarier, I guess, but if you look at it carefully, it's just the criteria query that you would write by hand when you're using JPA. Oh, something wrong here. Okay, this is using equals. Now, this is something we are in the process of sorting out in Jakarta Data, but we haven't sorted out. Typically, when you want to find a book by its title, you want to have some wildcards or something like that. You want to use a pattern. So, as a stopgap measure in Hibernate, this is for now until Jakarta Data makes this comes up with a standard solution. We have the pattern annotation on that, and now if you look at the implementation, it'll use the like operation. What about a query? Let's see. So here we have, a simple query. Find a book where the title's like something. Now here is something I want to point out that not to criticize IntelliJ or something, just to point out a little wrinkle here. Jakarta Data doesn't require that you type from book there. Okay, book is implied by the return type of the method. Unfortunately, IntelliJ just in this release doesn't know about that. They'll fix it very soon, I'm sure, and so it gives you an error. But if you see Hibernate accepts that completely. So once again, I promise you that this was checked at compile time. So what happens if I misspell the name of the entity, right? First of all, IntelliJ tells me, right? But also, I'll get an error for Hibernate if I try to compile it. Could not resolve root entity boo. Okay. If I misspell an attribute, again, IntelliJ catches it, but so does the processor. Could not interpret path expression. But okay. As I said, there are some more things you can do. Oh, sorry, I need to show you the implementation. So this is what the implementation looks like. Again, this is like completely transparent. This is the code you would write yourself to call that query. Okay, there's nothing, there's nothing hiding. There's no, and there's the query itself. There's some more things we can do. For example, we have this, if I want to reference a field of a field, how do you call that? If it's with parameter-based query methods, then I can do that using this underscore syntax. And so you can see that the criteria query that's generated does get author.name.getName.first. Okay. Do I love this? Maybe not, but it's okay, and it's type safe. If we mess up, Hibernate will catch it. There you go. So I haven't shown you any operations which update the data. I'm going to show you, because I think it's cool. I mean, because they're mainly trivial. I will show you the this one. So the save operation in Jakarta Data. So we have insert, update, and delete, but we also have save. Save is kind of like a insert this if it doesn't exist, insert this object if it doesn't already exist in the database, or update it if it does. Okay? So in our implementation, that maps to stateless session.upsert, which I think is pretty cool, and that will do a SQL merge on the database. I don't know, anything else you guys want to see here? I think that kind of gives you the idea. You know, that gives most of the idea here. Obviously, you know, there's a lot more capabilities that are available here. One thing I wanted to show you is that, you know, over here on these other operations, Hibernate reasoned that these were non-null because ISBN and title, ISBN's an ID, and because title over on book is declared optional equals false. If I do that for author.social security number, which is not declared null, then you see that it takes note of the fact that this is potentially null and will accept a null argument here. But if you want that to be non-null, you can use the Jakarta non-null annotation, and it will generate the correct code. So we got 7 minutes for somebody to ask a question. Come on. Yes? Would it be possible to define the find queries on the entities? So this is a question, this is like a request for, what do we call that? As in Panache, active record pattern. No, it is repositories. Hibernate, on the other hand, tolerates more things than just repositories. Okay, so Hibernate's, I haven't talked about that at all today, but Hibernate will actually let you do things like that, and it will generate static operations, okay, rather than a repository. So Hibernate will support that, but it's not part of Jakarta Data, and I doubt it's going to be part of Jakarta Data. That's an interesting, and in particular Panache. If you look at Panache and Quarkus, then we've been having a lot of discussions about how to make this stuff all work nicely in Panache. Anybody else? Yes.
What about mapping to a DTO?
Mapping to a
DTO. Data transfer object.
right. Yes. Good question. There is nothing defined as of now. There are some discussions in the Jakarta Data group around around, I don't know quite how to characterize this, because the way I characterize it and the way other people characterize it is slightly differently. But essentially around having a query which returns some kind of type-safe projection object, right? Currently this is not possible, all right? It is possible in Hibernate. It is not possible in Jakarta Data. We are working on it, right? There is this is something that I want to make small, but other people would like to make it somewhat beefier, right? And so I don't want to make too much comments about what will ultimately emerge from that. But yes, it's something we are talking about, indeed. Yes?
Equals and hash code on entity.
Yeah.
It's a bad idea previously, but are there any...
It's a bad idea to implement equals and hash code? Or what?
Because in IntelliJ
Uh,
I'm going to mention a annotation processor is Lombok. You get the warning like, hey, don't do that.
so I don't, that's not what we say. Okay? Now look, this is something where if you go and read people's blogs, you'll hear opinions. And if you come and ask us, you'll hear a different opinion. In my opinion, entities should implement equals and hash code. And how should they implement it? They should use the natural key of the entity, okay? And this comes back to the question of, oh, but I'm using surrogate keys, right? I'm using synthetic generated entities. Okay, that's fine. But your entity still has to have a natural key, okay? It does. I don't believe when you say no, otherwise you don't have a proper entity, okay? Relations, well, these are supposed to be sets, okay? There has to be a natural key. Otherwise, you just have bad data, yeah? So it's a question of identifying what is the natural key of my entity, which is not the synthetic key, and implementing equal and hash code based on that. That's my take. That's my opinion. Other people disagree with me, but yeah. That answer the question?
Yes.
Good. Okay. Yes?
It will be possible to mapping a more complex query where the parameters are optional. You will have
Right. Yes. Absolutely. That is the first thing we're working right now in Jakarta Data. I've shown you how you can do it with optional order by sorting. Right. 100%. The top priority we have is to extend that to restrictions. How is it going to work? It's okay. If I have to in 30 seconds. Oh no, I actually have a bit more time than that. Characterize it in the most stupidest way. Right. It's like a mini criteria, a JPA criteria API that's just for expressing restrictions. But it's not going to look. It's not going to be a dog's breakfast like the criteria API. It's going to be something that looks more like what you saw with orders. Okay, so book.isbeyond.equals blah blah. Okay, so that design work on that is already we're drilling down on that. Okay, that will come in the next release of Jakarta Data for sure. Okay. Yeah. Anybody else? Yes. Support for reactive streams, yes, that is also something which has been discussed. So, in principle, the spec is written in such a way so that, as Hibernate's implementation supports this, right? So that you could have operations in repository which return reactive objects like uni and multi in Mutiny. Okay, spec is written so that. But that's not something defined by the spec, but that's something that an implementation could go on and add, okay? At some stage, it is possible that Jakarta Data will, might standardize that. The issue with that is what reactive API would we standardize on? We can't do Mutiny, we can't do, so it's something that is in Hibernate's implementation. It's something that is not part of the spec. That's my answer to that. I can't hear, I'm sorry.
Implementation is very much behind the scenes, so you cannot rely on particular implementation. It's has to be exposed by
Absolutely, yeah, no, if you want to do reactive persistence, you need Hibernate reactive behind that, right? It has to be reactive all the way down the whole thing. The repository has to be reactive. Hibernate has to be reactive. The JDBC, not JDBC, but the database client has to be reactive. It has to be reactive all the way down. Okay, we have that. Okay, but not in the spec. Okay, today I've been talking about the spec. Yes.
What is the synergy with domain-driven? Because there are many developers who assume that when you have an entity, it needs to be converted into a domain model. How does this work together in the broader scope of an application? Do you recommend converting the entity into a domain model before doing operations on it?
To me, an entity is a domain model. Okay, the entity classes are your domain model. The repositories are some persistent services which are, I don't know whether I'd put them next to or over the top of in terms of the layered architecture. No, next to, okay, which mediate interaction with the database, okay. And then, yes.
So there are many developers who like add an additional layer to convert it. I see that a lot lately. So to you, it's not needed actually.
Yeah, they're about to cut off my mic, so ask me in a second. Okay, thank you very much, everyone. Appreciate it.
All systems are nominal. Initialize Genesis sequence.